So today, we're going to talk about both ions and isotopes. So we'll just summarize what are some of the key points I wanted you to take away from that ion investigation we did in class Friday. And then we'll move forward and we'll talk about what isotopes are. So to start, ions are just charged atoms. Okay, so make sure you know when you hear the word ion, the atom now has an electric charge. So that means that if you hear the word atom, atoms imply that it's neutral. Okay, so if you hear the word atom, it means it's going to be neutral, meaning your protons and electrons will be the same number. And then from this point forward, if you hear the word ion, ion implies that it's charged, meaning that the protons and electrons are not going to be equal. Okay, you with me there with like our vocab definitions? Okay, so atoms will be neutral, ions are charged. And so then ions form when atoms either lose or gain electrons. Okay, so make sure you know it's electrons are what make ions form. And so something I liked about that simulator you could use on Friday is you could play with the different number of protons and neutrons and electrons, and it had like the little net charge counter. So I think the first atom you turned into an ion was oxygen. Do you remember that? You had to build oxygen, and then it asked you to make it oxygen with -2 charge. Does that sound familiar? Okay. How many of you tried to change the number of protons? Okay. And what happened? If you used that simulator on Friday, if you changed the number of protons, what happened? Okay, it changed the atom, right? How many of you remember it's like if you changed the protons, the name changed? Okay, so you can't change the number of protons. How many of you tried changing the number of neutrons? Okay. If you did the charge change? No, because do neutrons have a charge? Okay, so that means it has to be electrons, right? So if an atom becomes an ion, it's because the electrons are either added or taken away. And then at the very end of that investigation, on Friday, there were a couple questions that basically asked why. Okay, so why do atoms either lose or gain electrons to become ions? Do y'all remember that question at the end? Why do atoms become ions in the first place? Why would they gain or lose electrons?
Isn't it because they want the maximum valence electrons in the outer shell?
Good. It's to fill up the valence shell. Okay. How many electrons do most atoms want in that outer shell? 8. Okay. So the whole reason why atoms gain or lose electrons is to get how many electrons in the outer shell? 8. Okay. So there's 2 types of ions. The first one is cation. Everyone say cation. Okay, cations are positive. And in order to have a positive charge, it means you have to lose an electron. Okay. So cations lose electrons. The second type is an anion. Everyone say anion. Okay, so anions are negative ions, or they have negative charges, which means they have to gain electrons. Okay, so I just want to do a couple practice problems. This one is just like the warm-up. Again, we're just going to count protons, neutrons, and electrons for the following ions. So our first one is O with a 2-. I'm just going to rewrite it. When I switch to my recording software, it changes my format. It doesn't like the superscripts, but it's an O, and then the 2- is a little superscript. What element is O? Okay, it's oxygen. So get your periodic table out, okay, and then find oxygen on that periodic table. How many protons does oxygen have? Okay, 8. How many neutrons? Okay, the mass is going to be 16, so it's 16 minus 8. 8. And then finally, electrons. Oxygen has a -2 charge. So does it mean it has to gain 2 or lose 2? It gains 2. So how many electrons? 10. All right, next is Sn plus 2. Again, I'm just going to rewrite it so it's the correct format. Okay. What element is Sn? Okay, tin. So find tin, or Sn, on your periodic table. How many protons does tin have? Okay, 50. Let's do neutrons together. If you look, what's the mass of tin?
118.7.
Okay, I'm going to do this one at the top, just out of the way. So 118.7.
710.
Okay, that's good enough. What would you round that to?
119.
Okay, so you're going to round that to 118 and then subtract 50. So what's 119 minus 50? Are you getting 69?
Yes.
Okay. Are we okay on neutrons? Okay. And then electrons, if it has a +2 charge, does it gain 2 electrons or lose 2 electrons? Okay, it loses 2. So how many electrons? Good. Okay. This last one is phosphorus with a -3 charge. Try protons, neutrons, and electrons on your own. And then we'll check answers in like 20 seconds. Okay, how many protons for phosphorus? Okay, 15. How many neutrons?
16.
Okay. I think it should be 16. Do you round it to 31?
Yeah.
Okay, 16. How many electrons?
12.
I hear 12, I hear 18. Okay, -3 means you've got to add on 3. So 18. Okay, we're moving on to ions, or not ions, we're moving on to isotopes. Before you copy the words, just look at this picture up here. Okay, so these are hydrogen atoms. How many hydrogen atoms are up here? Okay, take a look at those 3 atoms. What's different about the 3? Okay. Turn to someone next to you, tell that person next to you, what do you notice that's different? Okay, what are we noticing that's different? The neutrons are changing, right? So this first one, it's called protium. It just has 1 proton, no neutrons. Deuterium has 1 proton, 1 neutron, and then tritium has 1 proton, 2 neutrons. Okay. They all have 1 proton, so what element does that make them all? Hydrogen. Hydrogen. So they're all hydrogen. However, they're a little bit different, right? Their number of neutrons differ. Therefore, we call those isotopes. Okay, so isotopes are elements that have the same number of protons, but different number of neutrons. All right, so since isotopes have different number of neutrons, it means that the mass is going to change for each different isotope. Okay. So take a look here. This is still hydrogen. Remember back when we started this unit, we had that little table. Protons are found in the nucleus. They have a charge of +1. What's the mass of a proton? If you don't remember, look at that little chart we copied down at the very beginning of this unit. Okay, 1 AMU. And what's the other subatomic particle that has a mass? Okay, so protons are 1 AMU. Neutrons are also 1 AMU. All right, so if we look at protium, protium has 1 proton. So what's its mass? Just 1. Okay. Deuterium has 1 proton and 1 neutron. So what's the mass of deuterium? Okay, 2. And then tritium has 1 proton and 2 neutrons. So what's the mass? 3. Okay. So isotopes will have different masses because they're going to have different number of neutrons. Okay. So that means if we're looking at isotopes, we can't see the nucleus, so we're not going to actually be able to see the number of protons or the number of neutrons. However, we can figure out isotopes because the masses will be different. Okay. Does that make sense how we would know isotopes exist? They're going to have different masses. All right, so we're eventually going to learn how to count our protons, neutrons, and electrons for isotopes. First, we just need to refresh. Okay, so mass number is how much one individual atom weighs. And what are our 2 subatomic particles that have a mass? Do protons have a mass? Yes. Do neutrons have a mass? Yes. Okay, these are our 2 particles that have a mass. So mass number is just your number of protons plus your number of neutrons. Mass number always has to be a whole number because can you have 0.3 of a proton or 0.3 of a neutron? No, right? So it's always got to be a whole number. So I just want to show you an example of how we would write different isotopes and figure out protons and neutrons for those isotopes. Okay. So this is an example of carbon-14. How many of you have heard carbon-14 before? Maybe. Okay. If you look at the periodic table, what would you round the mass of carbon to be? 12. So you would normally round it to be 12. Okay. That's the most abundant isotope of carbon. So if we have a more rare isotope, we always put the mass number. Okay, so 14 is a more rare, it's less abundant. So we write carbon and then just like dash 14. Okay, so go ahead and copy that and then just write yourself a note that this is the mass number. And so if we use our equation that mass number is protons and neutrons, we can end up figuring out how many neutrons are in the atom. Is protons ever going to change? Okay, so what's the atomic number for carbon?
12.
Top left number.
6.
6, right? Carbon's always going to be 6 protons. Always, always, always. Okay, so then to figure out your number of neutrons, you're now going to use the mass number given to you. Okay, if it's given, you're not going to use the periodic table. So you're going to use the number given. And we're just going to take our mass number minus our protons. So what's 14 minus 6? 8. Okay, so that's where that number comes from. All right, so in this slide, we're going to practice. We're going to count protons, neutrons, and electrons. So our first one is copper, 65. What is this 65 telling you? Okay, this is telling you the mass number. All right, so find copper on your periodic table. What's the atomic number for copper? Okay, 29. So how many protons? 29. Okay, protons don't change. It's always going to be that atomic number. Next, to figure out neutrons, you're going to take the mass number minus the atomic number. Okay, so 65 minus 29. Are you all getting 36? Okay, so 36 neutrons. And then for electrons, do you see any charges? Okay, so that implies it's neutral. So how many electrons?
29.
Okay, so 29 electrons. Okay, so when you have a problem like this where the mass number is given to you, we no longer look at the periodic table and round the mass. Okay, you're going to use the number provided. Yes, you with me there? Okay, next, let me rewrite this for my formatting. So it's chlorine with a -1 charge and a mass of 36. So I'm combining ions and isotopes in this one. So find chlorine on the periodic table. What's the atomic number for chlorine? Okay, 17. So how many protons? Okay, 17. Then we're going to find neutrons. We're going to use the number provided. So we're going to use 36. And we're going to subtract 17. Okay, what are you getting? Are you getting 19? Okay, and then this time, do you see a charge? Okay, so -1, what does that mean for electrons? Okay, it means you have to have an extra electron. So how many electrons? 18. All right, the last thing I want to talk about is how do we get that average atomic weight on the periodic table? Okay, so if mass number is a whole number, why do most of the atomic weights on the periodic table have a decimal, right? So like why is carbon 12.011? So we're going to figure out how do we actually calculate that number on the periodic table. So to start, I just have a scenario to kind of get you thinking like the right way we would calculate the average for the periodic table. So don't write this slide down, okay? But let's say I give out a chem test. Half of you score exactly 100%. The other half of you score exactly 75%. What's the average between those two numbers?
87.
Okay, it's 87.5. So like the class average would be an 87.5. However, did anyone actually score an 87.5%? No. So that's the same, like, it's a really similar comparison to atoms on the periodic table. Okay, so if we look at carbon, carbon isn't actually weigh 12.011, but it's an average of all the isotopes. So then today, we're going to learn how do we actually calculate that average atomic mass. So you have to know three things. First of all, you have to know how many stable isotopes there are. Then you have to know the mass of each isotope. And then third, you have to know the percent abundance. Okay. So like what percent of carbon is carbon 12? And what percent of carbon is carbon 14? Okay, you have to know those. And then once you know those numbers, we can plug it into the atomic mass equation. Okay, so average atomic mass equals M1 is the mass of the first isotope, and then P1 is that percent abundance of the first isotope. So we'll write mass is for M. And again, my computer doesn't like the format, but it's like M with the little 1 and then P with the little 1. Okay, P stands for percent abundance. And we're going to add to that. When you multiply it, you actually have to convert this to decimal form. So write yourself a little note, like change to decimal. Okay, and I'll show you. On our next slide, we'll do a practice problem. But when we calculate the average atomic mass, it's just the mass of that first isotope multiplied by the percent abundance in decimal form. Okay. Then you add it to the mass of the second isotope times the percent abundance of the second isotope. If you have a third one, you keep going. If you had a fourth one, you keep going. That's what that ... means. And before we move on, let's just refresh and review. How do you convert a percent to a decimal? Like, let's say we had 85%. How would you convert that into a decimal? What would you do?
Just put a decimal point in front of the 8.
Okay, so you have two options. You can move the decimal 2 to the left, or you can divide by 100. Okay. And then it doesn't matter. You'll do whichever one you prefer. So you could take 85, and could you type in 85 in your calculator and type in 85 divided by 100? Okay, and it'll give you 0.85. Or if you're just good at moving decimals in your head, could you move the decimal from here over 2 places to 0.85? Okay, so you pick. You can type it in your calculator, divide by 100, or move it 2 to the left. Okay, but if you're going to take your percent and change it to a decimal, you just move the 2 to the left or divide by 100. Okay, so we're going to do one practice problem where we practice calculating the average atomic mass for an element. So rubidium is a soft, silvery white metal that has 2 common isotopes, 85 rubidium and 87 rubidium. If the abundance of 85 rubidium is 72.2% and the abundance of 87 rubidium is 27.8%, what's the average atomic mass? All right, so the first thing, we just got to figure out our info. So you're given 85 and 87 rubidium. These are mass numbers. All right, so they're giving you the mass. How many isotopes are there for rubidium? Just 2. Okay, so we know there's only 2. We know the mass, and are you given the percent abundance? Okay, so you're given everything you need to find the average atomic mass. Okay, I'm just going to abbreviate down here. Average atomic mass. we're going to take the mass of our first isotope. So I'm going to take 85 as my first one. And what's the percent abundance of the 85 isotope? Okay, 72.2. What do you have to do with this percent, though? Okay, you've got to convert it to a decimal. So that's what we just talked about on the previous slide. So 72.2. You could divide it by 100. Okay, if you use your calculator, can you type in 72.2 and divide it by 100? Or if you're just a decimal mover, like you're just good at moving decimals in your head, can you just move it 2 to the left? Okay, the key is you just have to convert it. So 0.722. If I were you, I would write parentheses around it, and then you'd actually put those parentheses in your calculator. So it'll just help your calculator follow order of operations. And then we're going to do the same thing for the second isotope. So the second isotope has a mass of 87. And what's the percent abundance? Okay, it's the 27.8. And what is that in decimal form? Okay, so 0.278. Okay, so if I were you, I would write it out just like this, and then I'd also enter it in my calculator just like this. So I would actually put those parentheses in the calculator, and then just type everything in all across. And then type it in, because we need an answer. Do like Google Calculator. Once you get an answer, let me know. It should be somewhere between 85 and 87. Do you have a number? What's your number?
85.556.
85.556. Are you all agreeing? Okay. Sig figs, I won't be too terribly picky for sig figs. However, it should come from your percents. So how many sig figs here? 3. How many here? So how many should be in your answer? Okay, so what would you round your answer to? 85.6. And then our unit is an AMU, which is just an atomic mass unit. Okay, and then when you're done, you can check your answer a little bit. Let's see if it makes sense. It should be an average somewhere between 85 and 87. Okay, and does that number fit within that range? Okay, and then it's also going to be closer to the isotope that's more abundant. Okay, so 72.2% of rubidium exists with a mass of 85, whereas only 27.8% exists with a mass of 87. So does it make sense that this number is closer to 85? Okay, so it should. Those are like things you can think about to see if like your work is making sense. So since this one's more abundant, your number should be closer to 85. And is it?